In today's session, we are supposed to see about the VI characteristics of diode. When we have seen the working of the PN junction diode, at that time we have seen if we are giving external power supply to the diode, at that time that process we are saying as a biasing. And when we are giving the positive supply, when we are connecting positive terminal of a battery to the p-type semiconductor and negative terminal of a battery to the n-type semiconductor, at that time that biasing we are saying as a forward biasing. In that you will be get flow of current. But if we are giving negative supply, it means what? If we are connecting negative terminal of a battery to the p-type semiconductor and positive terminal of a battery to the n-type semiconductor, at that time the width of depletion region will go to widen. Depletion region जो है वो बढ़ जाएगा, due to which barrier potential will increase, and due to which there will be no amount of current will flow, or there will be very less amount of current flow because of the minority charge carrier. But in the forward biasing, current is flowing due to the majority charge carrier. These are nothing but electrons in the n-type semiconductor and holes in the p-type semiconductor. So now we are supposed to see its VI characteristics. VI means what? Voltage with respect to current characteristics for a PN junction diode. So if we are giving the positive supply, at that time you will get forward voltage, forward current. So you can see here the diagram for the VI characteristics of the PN junction diode. If we are taking positive voltage, at that time you will get the current that will be the positive. So we can say IF मतलब forward current. जो ऊपर का I लिखा है उसको you can write IF, and you can see in the first quadrant we are saying forward operating region, because when we are giving the forward voltage to the diode, at that time current is flowing due to the majority charge carrier. And when current will flow, you can see for some time, if you see this diagram here only, now you can focus on the first quadrant. So here you can see when we are giving the positive supply to the PN junction diode, at that time if supply voltage will become exactly equal to the barrier potential, and when it will goes increased as compared to the barrier potential, at that time there is an increment in a current, and this increment is nothing but a sudden. You can see here यहाँ पे जो लिखा है, यहाँ पे डैश लाइन में 0.3 वोल्ट फॉर जर्मेनियम, 0.7 वोल्ट फॉर सिलिकॉन. These are nothing but barrier potential or the barrier voltage which will be required to increase current with respect to voltage. So in exam there you will get the question barrier potential for silicon. In there you will get a blank space. There they will give four options: 0.3 volt, 0.7 volt, 1 volt, 1.3 volt. At that time you are supposed to understand for silicon you will be needed 0.7, and if there is a germanium, at that time we are using the 0.3 volt. So these are nothing but the barrier potential, or you can say that voltage as a cut-in voltage. वो वोल्टेज को हम क्या बोल सकते हैं? कट इन वोल्टेज, और यू कैन से अनदर थर्ड वर्ड, we can say knee voltage. You can see here I have given here the name V suffix K and double E. This is nothing but knee voltage. So if there is a question in the exam, cut in voltage for silicon, knee voltage for silicon, or you can say here that is nothing a barrier potential, all are having the same meaning. Okay, so here we are saying when we are giving positive supply to the diode, at that time at start there will be no amount of current will flow. You can see here up to dash line there is a no very small current is flowing, but when given supply voltage will reaches to the knee voltage, at that time there is a sudden increment in a current with respect to voltage. That current you can measure in a ampere. So you can write here I के बाद bracket में तुम A लिख सकते हो, because this is the unit for the current. So if there is a question in the exam, now you are supposed to go for the MCQ, but always if you see the exam pattern, at that time you are supposed to go for descriptive question, and if there is a question like you are supposed to draw फॉरवर्ड कैरेक्टरिस्टिक्स फॉर अ पीएन जंक्शन डायोड. एट दैट टाइम ये इतना पूरा डिराइव करने की जरूरत नहीं है. ओनली फर्स्ट क्वाड्रेंट, ओनली first quadrant, only this diagram is needed. Only you are supposed to show voltage on a x-axis, current on a y-axis, and at start there will be no amount of current flow, or you can say very less, but from knee voltage 0.3 or 0.7 volt for a silicon, from that voltage there is a sudden increment in a current, and that voltage we are saying as a knee voltage or cutting voltage. So these are the forward characteristics of a diode. Have you got the forward characteristics of diode? If anyone is facing any issue, you can ask me. Otherwise, we will move to the reverse characteristics. यहाँ पे किसी को कुछ समझ में नहीं आया है तो तुम लोग पूछ सकते हो. Is there any issue? हाँ, बोलो. Okay, फास्ट हो रहा है थोड़ा. Okay, okay, it's fine. ठीक है. See here, when we are connecting positive terminal of a battery to the p-type semiconductor and negative terminal of a battery to the n-type semiconductor. At that time, what will happen? We are connecting positive terminal to the p-type semiconductor. और p-type semiconductor में क्या है हमारे पास? होल सेल. तो क्या हो जाएगा यहाँ पे? रिपल्शन होगा. Positive terminal of a battery will repel the holes of p-type semiconductor and they will get pushed towards the junction and they will enter into the n-type semiconductor. And at that same time, we are connecting negative terminal of a battery to the n-type semiconductor. n-type semiconductor में हमारे पास क्या है? इलेक्ट्रॉन्स है. और हम क्या कर रहे हैं? निगेटिव टर्मिनल बैटरी का उसको कनेक्ट कर रहे हैं. तो क्या हो जाएगा? अगेन देयर विल बी द रिपल्शन बिटवीन इलेक्ट्रॉन एंड द negative terminal of a battery, due to which they get pushed towards the junction. क्या हो जाएगा? वो फिर से जंक्शन के पास पुश होगा, due to which they will start to go into the p type semiconductor region. यहाँ नेटवर्क का भी इशू हो रहा है.